Hello class, now we are going to start with the probability theorems. In probability there are two theorems, addition theorem and multiplication theorem. These theorems will let you solve the questions of probability with the ease. So first, addition theorem says if two events A and B are mutually exclusive and the probability of occurrence of A is probability A and that of B is probability B, then symbolically you can say probability of A or B can be denoted by probability of A addition symbol probability of B. That means if any of the question says probability of happening of one event or the other event, then you can solve this with addition theorem itself. So if there are only two events, if there are more than two events, you can also do it like this way, as it is given here A or B or C, then you can expand this theorem also. So let's take up a question over here. If a card is drawn at random from a pack of cards, what is the probability that the card drawn is either a king or a queen? So it clearly says either or. That means you have to opt for addition theorem itself. So in second question also it is saying either a club or the ace of diamond. So here also it is saying either or. So you are going to opt for the addition theorem. Next is either a spade or a king, either a queen or a red color. So these all questions signifies that we have to opt for this addition theorem. Let's solve this particular first question. Either a king or a queen. So probability of drawing a king we can assume as probability of A, and probability of drawing a queen from a pack of 52 cards will be probability of probability B you can say. So in this case, a probability of drawing a king, number of favorable cases would be, so there are 4 kings in this particular pack of card. So one of heart, one of diamond, one of spade and one of club. So we will be having 4 favorable events and total number of events will be 52. That means 1 by 13 is the probability of drawing a king, and another probability of drawing a queen similarly would be 4 by 52. As you know that there will be a queen in the heart cards and diamond and spade and club. So here the probability will be 1 by 13. So probability of drawing a king or queen will be denoted with this addition theorem. So simply you are going to put the so this will be the probability of getting a king or queen is 2 by 13. So the next question asks for the probability of drawing a club or the ace of diamond. So here also you are going to denote the probability of drawing a club as probability of A and another probability of drawing a card of ace of diamond, that you are going to keep it as probability of B. So probability of A, that means probability of drawing a club. How many cards do we have of club? 13 cards. So 13 are the favorable events and number of total events will be 52. Next will be probability of drawing an ace of diamond. So how many ace do we have of diamond? Only one will be there. Ace, how many ace are there? Only one. So it will be 1 by total number of events is 1 by 52. So probability of drawing either a club or the ace of diamond can be denoted with this addition theorem, and simply we are going to keep the values 13 by 52 plus 1 by 52. That means the answer would be 14 by 52, that is 7 by 26. So this is how you're going to solve the questions. Next is, so the next problem is probability of drawing a spade or a king. For this we are going to disintegrate into two parts. Probability of drawing a spade is termed as probability of A, and probability of drawing a king is probability of B. So we are simply going to get the probability of drawing a spade is, how many spades do we have? 13 cards we have as the favorable events, and divide by total number of events. And probability of drawing a king, kings, how many do we have? 4 kings upon 52. So this is clear, but there is one problem, that we are having one card of king which happens to be in spade 1. So it shows, you can clearly see this thing, probability of A and probability of B is somewhere one such condition is coming in between. So this type of question should be dealt with the modified formula. So modified formula should be used in case of non-mutually exclusive. So there is one such condition which neglects the exclusive events. So if there is such condition when there is non-exclusiveness, then you are going to opt for this particular formula. Simply you are going to deduct that particular condition where there is a linking of these two probabilities. So we are simply going to write it as probability of A 13 by 52 plus 4 by 52 and minus how many conditions are there where these two probabilities are interlinked. So there is one such condition, because probability of drawing a spade as well as king. So here, as you can see in this spade cards, there is only one king. So this condition will be denoted by 1 by 52. Number of favorable event is 1 and total number of events is 52. So we are going to simply deduct this thing, and we are going to get if you're simply going to solve this thing, then it is going to come 16 by 52, and which simply says it is 4 by 13. So the last question says probability of drawing a queen or a red color. So again, probability of drawing a queen will be, how many queens do we have? 4. 4 by 52. Again, probability of getting a red color card is, red color cards we have 26 by 52. But there is one such condition where basically there are two conditions where there are queen of heart and diamond are common in probability of drawing a queen and as well as in red color. So its probability would be 2 by 52. So we are simply going to put these things in our formula, and you are going to get 4 by 52 I hope this is clear.